when you try to go for summation or adding together or multiplying together, so of course we are finding a different probability result. The total candidates are available 32. So we set for A, the probability A set for Indus. The multiplication theorem states that if two events A and B are independent, okay, when event A is completely different from event B, so which is independent. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Session 4, third semester BCom Business Statistics. So, which is the third unit of probability distribution. And today my agenda, in the last two session, 3 session I have covered which is classical approach and subjective or empirical approach. Now we are in the modern or axiomatic approach to the probability. When you are assigning a probability, so which is the latest and modern method, okay, with the help of a modern and axiomatic, which is nothing but your statement, okay. So under the modern and axiomatic approach to probability, so the first one, the probability rule for addition and multiplication. So addition theorem or law, or you can say law of probability and independent events, okay. So even the addition theorem, law or which is a dependent events. So last one is a multiplication theorem, okay, or law or rule of probability independent events. So moving forward one by one, so we will get to know the meaning once again. So here modern or axiomatic means, axiom means what, which is a statement. So the modern theory of probability is based on the axiomatic approach or statement approach, you can say. So which is introduced by the Russian mathematician A.N. Kolmogorov in the year of 1930. So this person is introduced the modern or axiomatic approach of probability. So axiom, the theory of probability, and in his book, okay, he has written the book which is related to the modern approach, okay. So in this modern approach, the probability is an undefined concept, okay. Moving forward one by, so here the number of problem we have to obtain combined probability of event A or event B or event C or event 3 till n numbers. So the probability, whenever you are trying to go for number of if there is a multiplication or addition theorem, okay, when it is related to the axiom, so definitely we need to set an event. So by adding or multiplying, because the different events when you are finding, definitely we need to add together. So when we are doing for addition or multiplication, the rule of pertaining to the addition and also multiplication are discussed here under, because when the different event is going on, when you try to go for summation or adding together or multiplying together, so of course we are finding a different probability result, okay. So there may be two types of environmental. One is when the event are independent, okay. For example, wife, when you try to compare wife and husband, you can't compare with the wife, so both are independent. The age also independent, okay. The earning capacity also independent. So one event A, when you are expecting, event B is not occurring, means which is an independent event. When the event are dependent, so in case of any, for example, a children is always depending on the family or parents, okay. So now the children's coming under dependent, okay, parents are independent. So when you are trying to set a event for children as well as parents, how to add or multiply when the event are independent or dependent, in the subject matter is the discussion. So because that based on the experiment, based on the event only, we try to go for adding or multiplication, okay. So these are also called addition and multiplication theorem, okay, because we are adding the event, different events we are adding, or you can say it is a law of probability, okay. Moving forward, so in addition theorem is also addition law or addition rule of probability, because when you are trying to add any event, so you need to follow the addition rule, addition probability conditions. Okay, so it is applied to event which are mutually exclusive, because we know the concept, the basic concept which is related to the probability: equally likely, exhaustive, mutually exclusive. Okay, event A occurred means event B or not, which is not occurring. Okay, so different types of nature of event what we are finding. The addition theorem state that if two event A and B are mutually exclusive, okay, or cannot happening together, when head came means tail is not coming, when tail came means head is not coming, when hard numbers came means even number is not occurring. Okay, so in that case, the probability of occurrence of either A or B, the same time you can't expect both the event. Okay, either you are expecting A or B, denoted by, because prob P of A union B, P of A union B, because we are together, we are writing. Okay, so the symbolically we are adding together the probability A and probability. For example, the probability A set for the odd number and the probability B is set for the even number. When you are writing the total dice result, we are writing 1 to 6 we are writing. So, is the sum of the individual probability of A and B. Symbolically, P of A, how we can expand? Here see the P of A plus P of B, or you can write P of A or B, or same thing, the additions only we are finding P of A and P of B, because adding different events together, so which is nothing but addition. Okay, so here U stand for union, because together when we are writing the different events what you are expecting from the result. Okay, the theorem can be extended the 3 or more mutually exclusive event. In this case we are able to get there are 2 events, but in this case the number of events are increasing. Okay, it is extending 3 or 4 or 5 or it is increasing. When it is increasing, then also we are adding P of A union B union C. Okay, P of A first event, P of B second event, P of C third event, or you can write like this: P of A or B or C. Okay, the same addition theorem we are following here. Okay, the same procedure. When we are trying to solve the problem, you will get more clarity. Okay, so which is related to the addition theorem or rule of probability independent. The first problem we are trying to solve independent event. So event A which is not connected with the event B, event B is not connected with the event A, so which is completely independent. So here the question number 1, one card is drawn from the deck of 52 cards. Okay, the pack playing cards. Okay, 52 cards we are able to identify. So what is the probability that it is either king is independent, okay, even queen is also independent, so both are not related, which is not dependent. Okay, so for example in this question, the question which is related to king, so the total playing cards we are getting 52 cards we are identified. So in this 4 cards belongs to king and 4 cards is a queen, so therefore 4 king and 4 queens in a deck of cards we are identified. The probability when you are writing 4 divided by 52. The probability of drawing a king, so now let it be the event is we consider A is a king, B is considered for queen. So P of A, 4 card we are getting king, out of total card is 52. Okay, or you can after simplifying 4 ones are 4 13s are, you can write like this also. Okay, next moving forward, the probability of drawing a queen. Okay, we set for the event B stand for queen. Okay, here the 4 queen we are expecting out of 52 card. Again we can simplify 1 by 13. So once you getting the separate king and queen, now we are trying to go for addition rule. Okay, so as the event are mutually exclusive, when king came means queen is not appearing, when queen is appearing means king is not appearing. Okay, so again what we are drawing, the probability of drawing either a king or queen is when we are writing like this union format, addition format. So P of A plus P of B. P of A 4 by 52 because king and queen is 4 by 52. So either you can write the same 4 ones are 4 13s are. 4 ones are 4 13s are. So finally, when plus or minus sign when we are getting, we need to take the LCM. So directly 13 is an LCM, 1 plus 1 2. So the probability of getting, okay, so 0.1538. Moving forward for next question. So here there is one more question which is related to what you need to identify, which type of experiment. So the probability that student X will solve a particular problem, okay. So the chances of 1 by 8, the solving a problem, one student, X student, any student, okay, 1 by 8. And then the probability of that another student Y, okay, now which is symbolically student 1 X, student 2 Y, will be solve the very problem, okay. The problem is 1 by 3. What is the chance of that either X or Y will be solve the problem, okay, either X, the first student or second student, okay. So the chances of X solving the student 1, first student, okay, so it which is clearly specified 1 by 8. So we set for the probability of A, okay, P of A, the first student, P of A, 1 by 8. The chances of Y student, second student, okay, the solving a problem, so P of B, we set for event is a B for second student, 1 by 3. Okay, now we are trying to take the addition theorem. We are following addition theorem. So what we are doing? We are trying to go for combining. So the chances of solving the probability either by X or Y. Okay, so because the question is either X or Y. So now we need to follow the addition theorem. P of A or B or P of A plus B. Okay, both are same. So P of A plus P of B. So when it is clearly specified in the question, 1 by 8 plus 1 by 3. Whenever plus or minus we are getting, so take the LCM. Okay, now LCM is a 24. 8 3s are 24. Okay, now 8 1s are. Okay, 8 3s are. 3 1s are directly 3. Now 3 1s are 3 8s are 8 1s are 8. Now together if you are taking 11 divided by 24. So the final probability 0.46. So yeah, there is one more question which is related to addition theorem. So here 11 Hindus, 5 Sikh, okay, and 7 Claylons and 7 Burmese and 2 Pakistan apply for the job in the embassy. So where only one candidate has to be appointed out of the total candidates from the different category. So if every candidate has an equal opportunity for this election, okay. So the question is, what is the probability of the post going to Indian? So in this year, which is Indian, 11 Hindus Indian and 5 Sikh Indian. Okay, now the total availability, the candidates, the total number of candidates are 11 Hindus, okay, 5 Sikh, 7 Sikhs, okay, 7 Burmese and 2 Pakistan. The total candidates is a 32. So out of 32, so what is the probability the one post is going for the Indian? Okay, so the total Indians are 11 plus 5, 16 candidates. Okay, here the probability that Hindu be selected, okay, because we are expecting a Indian candidates. Okay, so he is also belongs to Indian. He is also belongs to Indian, okay, compared to other. So here the Hindu chance 11 clearly specified. The total candidates are available 32. So we set for A, the probability A set for Hindus, okay, and the probability of getting a Sikh being a selected, because Sikh we are identified 5, okay, so 5 out of 32. So the total 11 plus 5, there are 16 Indians. Okay, so we set for event B is a Sikh. The probability of the post going to Indian when we need to take the addition. So that's what the union format we are writing, P of A or B. Okay, or you can write P of A union B. Okay, so if you are trying to extend according to addition format, so P of A plus P of B. P of A we know 11 by 32. P of B we know Sikh is 5 by 32. Where there is a plus or minus sign, then we are taking LCM is a 32, the common LCM 32. 32 cancel means 11. Again here 32 cancel 5. Together if you take 16. So the probability of getting chances for Indian is 0.5. Under independent, now the previous problem which is related to independent. Now moving forward for the addition theorem, so which is related to dependent event. So now just now I told on example the children is always depending for parents, right? So here the any specific event is depending for other event, so which is completely dependent event. Okay, in that case addition theorem how it is. Okay, so there is one question, what is the probability of drawing either spade, okay, and ace, okay, in a single draw from a standard pack of 52 playing cards? Okay, because we know there are two colors, red and black. We know there are four designs, okay, spade, club, heart, okay, and the diamond. So even when complete the spade also you are able to identify there is one ace, okay. In the ace which is belongs to spade, which is belongs to diamond, which is belongs to heart, which is belongs to club. Okay, so based on the color we will get to know there are two colors belongs to ace. There are red color also we are getting, there are two ace in the question. Now when ace is completely depending on spade, okay, so obviously as the ace of a spade can be drawn in the both way, in spade and also in ace. Okay, when you try to pick one playing cards, either which is belongs to spade, because the different four design we are getting now. So there are two black colors also we are finding and two red colors also belongs to ace. Even the design, each and every design we are able to identify there is one ace. So as a two event, A is a spade, B is a ace, you need to set the event are not mutually exclusive. Therefore, the probability of drawing either spade or ace. Okay, now you need to write additional format. Okay, so when you are writing, of course, you need to go for, okay, so P of A which is belongs to spade, P of B which is belongs to ace. Now P of A into B. Now P of A into B we need to get. So because if the ace what you are getting which is belongs to spade, now when it is belongs to spade, now you need to multiply. So that's what I have written here. So P of A total 13 spade card out of 52 playing cards. Okay. So in the out of 52 cards we are identified there are 4 ace. Okay. So the color, numbers, everything, the color basis, spade design basis we are getting. So the total ace is 4 out of 52 playing card. Now from this you need to subtract which is a common, which is a dependent. Okay. Now here are the same thing. 13 divided by 52 into 4 divided by 52. Now in this case we need to take the LCM. For that reason I have written as it is. Okay, 13 by 52 plus 4 by 52. Now if you try to go for after multiplying 13 ones are 13 fours are. Okay, 4 ones are 4 13s are. Okay, so 13 fours are 52. Okay, here 1 into 1 we are getting. Okay, so again because plus minus sign when you are identified, now completely the 3 you need to take the LCM, the common LCM after identified. So first we are try to go for solving this one 13 by 52 plus 4 by 52. So here 13 52, so 52 cancel 13. Okay, 52 cancel 4. So 13 plus 4 17 by 52. Now you need to subtract. So for that reason I have written one more time minus 1 by 52. So for that reason you have to take one more time LCM. 52 is a common LCM. 52 cancel 17. Okay, again in this the minus sign 52 cancel. Okay, 1. Okay, 17 minus 1 16 by. So after calculating, simplifying, we are getting 0.308. Now AB is nothing but A is the event of spade, B is the event of ace. see multiplication theorem later. Okay, so next moving slide, we are able to get more clarity about the multiplication theory, because which is the ace is belongs to spade. So for that reason, we need to multiply. Okay, moving forward. So there is one more question, dependent event. A construction company is bidding for two contractor A and B. The two contractor directly A and B. Okay, event A, event B. So the probability that will be getting contract A is the chances of 3 by 5 and B chances is 1 by 4. Okay, so A is a different contractor or they are dependent. Okay, so definitely they are dependent means of course getting a probability. So the getting a contractor. Okay, so the probability of that will be getting both the contractor are getting chances, because which is completely dependent. Okay, 1 by 8. What is the probability that the company will get contract A or B? So now we need to write a addition format. So for that reason, P of A or B, P of A belongs to contract A, contract B. Now minus, when they are specifying both, now we are writing multiplication. Okay, so here the probability contractor A 3 by 5 clearly specified, the contractor B 1 by 4 which is clearly specified in the question, and getting chances of both 1 by 8. If you try to simplify 1 by 1, okay, from this we are getting 0 point. Directly we can divide fraction value 3 by 5 0.60 plus 1 by 4 0.25. From this 1 by 8, so if you divide the fraction value, so from this you need to subtract the final ESC. If you add together, we are getting 0.85. From this we need to subtract both chances. So 0.12 if you subtract, so the getting chances will be 0.725. Moving forward, now we are in the multiplication theorem according to the agenda. So the addition theorem you got more clarity. Now moving forward for multiplication theorem. So or you can say law of probability. Here in this we are trying to focus on the independent event. Okay, independent. A and B are independent, both are separate. So which is not at all dependent. So the multiplication theorem, also known as multiplication law or multiplication rule of probability, is applied to obtain compound probability of two or more events simultaneously happening. Okay, when it is only two event or three event or more event. Okay, so when at the time of applying a multiplication theorem, so we need to follow some basic guidelines. The multiplication theorem states that if two events A and B are independent, okay, when event A is completely different from event B, so which is independent, the probability that they will be both occurring together, the probability we need to identify. Either the chances of getting event A, the chances of getting B. Okay, both are different. So what is the probability of both occurring together? So simultaneously on any one occasion is equal to the product of individual probability of A and B happening separately. Product means what? So when we are multiplication, when we are try to go for multiply, so which is nothing but your product. Okay, so symbolically, if A and B are independent, then the probability of A and B happening together is, okay, so when together, when we are taking, not we are considering for union, we will consider for intersection. Okay, so P of A intersection B is equal to P of A into P of B, or you can write P of A and B. In the addition theory, P or B or C, but here multiplication theory we are trying to focus on and. Okay, so if you try to extend the same, P of A multiply P of B, so which is nothing but your product. When we are multiplying, which is related to product. So the theorem can be extended to three or more independent events. Okay, in case of three or more events, we will extend nothing. We will extend P of A into P of B and P of C. Moving forward, there is one question for the multiplication independent. Two balls are drawn from a bag containing 7 red and 11 white ball. Okay, find the probability that one is red and one is white. Okay, so when a red which is independent and white also independent, so here the condition is with replacement after picking one ball. Now you need to take the total ball. How many balls are available? There are 18 balls are available. Okay, the total sample is 18. Okay, either you can use for combination format. Okay, with the help of combinations also we are trying to solve the problem. So that is also possible. Here with replacement after picking one ball for the first draw, again second time when you are picking one more ball, the previous ball you have to keep in the box or whatever the content or bag. So here the total ball in the bag 7 red, 11. The total ball is available for 18. Here the question is find the probability that one is red, one is white. So the probability of drawing a one red ball in the first draw, the chances, the total ball is 7 upon 18. So the first ball is replaced. Whatever you picked for the first time, again you are keep it back. Okay. So then also our total samples is 18 only. Now the ball is the bag 18. After picking first time, again you are keeping in the same place. Okay. So 18 only. The probability of drawing a white ball in the second draw, okay, the white ball, there are total 11 white balls. So 11 upon total 18 balls. The compound of probability of both the event happening independently. Now we need to go for multiplication. P of A and B. A stand for red, B stand for white ball. P of A into P of B. Now product we consider. P of A 7 by 18 into white ball 11 by 18. So if direct multiplication 7 into 11 77, 18 into 18 324. If you simplify we are getting 0.24. Okay, moving forward. There is one more question which is related to independent multiplication theorem. The probability that a man age 60 years will survival 10 more years. Man, okay, the chances is the probability is 2 by 5. Okay, and woman age is 50, surviving more than 10 more years. Man is also independent, woman also independent. So the probability of chances are 3 by 4. What is the probability? What is the chances that they will both survival 10 more years, both? Okay, now you need to multiply. So the survival of man does not affect the survival of woman because both are independent. The two events are independent. The probability that they will both survival 10 more years. Okay, the product we need to write here. So P of A stand for men, P of B stand for women. So here 2 by 5 which is clearly specified 2 by 5 into 3 by 5 which is belongs to women. Okay, if you try to multiply direct multiplication 2 into 3 6, 5 into 4 20. Now the probability of getting both are surviving is 0.3. Keep on watch for next section. Thank you.